Swayam Prabha. Digital India. Educated India.
Welcome back in our discussions on the crushers. We have been talking about how we break things. So, that is as we know in our whole material handling, in many times we need to reduce the sizes of the particles. That sometimes it could be a grinding to powders, or sometimes from a big rock to a small piece. Now, last class we have discussed about the classification of crushers and the different crushers we talked about. We discussed little bit of the gyratory crusher and jaw crusher, which are used as a primary crushing. We talked about that how our closed loop and an open circuit and closed circuit crushers are used. Now, today we will be talking about the secondary crusher, which you have seen in some of the flow diagrams of bulk material handling. Now, the objectives of today's class is to tell you about this cone crusher, which is a secondary crusher, along with some other type of secondary crushers. Secondary crushers means exactly when you get a very big size of rock, from there you directly cannot get it at one stage the very fines. So, they will have to step by step crush. So, at some stage we are doing say 1:10, or one is that is reducing size from 10 to 1, from 6 to 1, like that. But in a secondary crushing, we take the crushed material in the first stage crush, then you are putting into over here. From there again it can go to a tertiary crushing, and from there it will be going to a milling or grinding for making fine particles. So, now as in this figure you can see, we are talking about a secondary crusher, which is a cone crusher. We will be discussing about what are the constructional component of it, that how the cone is made a movement to inside a concave to concave, that is so that the material get crushed in between and they get discharged over here. Now, but while in a you are in a crushing plant or in a beneficiation plant, you come across with certain terminology which are used for exactly describing and then managing the system. So, we will be talking little bit that also. Let us go first. As you have seen that this a different type of crushers. Out of that, when we think of this our secondary crushers, it can be of two types. One is your by compression crusher, that is where in a compression crusher your material, this will be squeezed between two plates, and then when it is squeezed from that, you are giving a compressive pressure of it, then what will happen? They will get crushed, and then the crushed material will be falling, and then you can take it over there. Or this type of crushers, when you are under a compressions and then getting an impact, we are that mainly by compressing you are doing in case of your cone crushers, in gyratory crushers, but other crushers where the materials are broken by an impact. That is you have seen sometimes, even if you are taking out the in some of the nuts, if you are taking a chestnut, or if you are taking a your even this akhrot, how do? You hammer it and then break it, और मूंगफली से मूंगफली निकालने के लिए भी you take out that, you crush it. So, that is by impact or pressure. When a rock is there, in that rock when you give a big impact, then they will be shattering down. So, like that we get an impact crusher. Now, there are different factors that will affect this crushing type, that you will have to select the right type of crusher for the right type of rock mass, and then the whole crusher selection for your secondary crushing will be depending on what type of material you are having. You may be having this, the materials, if they are very highly abrasive, there if you want crushers, there what type of liner, if you are using a very abrasive material to crush by pressing between two plates, there must be proper liner, so that abrasive action do not damage the crusher plates. Similarly, the hardness of material, if you are having a friable rock, then they will very easily get broken into pieces. Then the density of the material, it will be giving sometimes very tough, sometimes some materials are very tough to break, it will not be breaking easily. Then there will be some the fragmentations will be depending on that what type of shape or what type of particle you need to find it out. And then also under what conditions it is working, it is a wet condition, dry condition, high temperature conditions, your low temperature conditions, in a confinement, in a open type, in a one side open type, there are different conditions may take place. So, the selection of crusher is also a big job. Now, in basically you have seen in the gyratory crushers, last time we have discussed that the material is fed into, that is where it is coming inside at that time, that is the gap will be determining in your feed size how much big size of material you can take, and then you find out after it is crushing, it is in a gyratory crusher, they will be giving the gyratory motions with the eccentric shaft, it will be moving, or in case of your jaw crusher, they will be giving a impact moving like that from that, keeping it in the, or you can give it in the, that is depending on where the pivot point is there, black type or Dodge type we have discussed last day. By that exactly when they are giving your, if it is a fixed plate, if your this plate is coming over here, then what will be the main gap which is there, that is called your set. Then the gap and set ratio, that will be giving you the reduction ratio. But some of the terminology which you will be coming across in selecting or in operating with a crusher is that blocking, bridging, choking, choke point, choke feed, packing and the reduction ratio. These are the terminology very quite often you will be finding. So, let us see what they mean. The blocking means your rock or ore is too large and the entire crushing chamber it cannot come. So, that means then what will happen, if any particle comes which is a very big, then rest of the things it cannot, it will be going as a spillage, it will falling outside and all. So, that is why in any crusher you will have to see the feed size which is coming over there will have to be done. So, now in a operational exactly in real life what will you do it? How will you have it? Suppose you are having the crusher's hopper, the material are dumped right at the truck is coming and they will be giving the material over there. So, in that case what will happen, that when your a truck is loading the material, then if a big boulder come, your crushers will get. So, to avoid that what is done, we will be using at the receiving section a grizzly. Grizzly is nothing but a hopper where the hopper side walls are not plates, but there will be rails they will be fixing, just like you will be having, you may be knowing about the cow catcher. In many of the gates you find out that some roller pipes are there with a gap, so that the cow will not go inside because his leg will go. I do not know whether the animal lover will be telling it is having a cow catcher is good or bad, that we do not know. But thing is that system is a grizzly. That means if you are keeping any rock is allowed to put on that grizzly, only that between the two rails whatever the gap, that material will go. So, you allow that thing to go to the crusher, then whatever the oversize will be coming, you take it out separately, maybe you again do a breaking, or you just you can if you go to any mines of iron ore mines, you may see that when the material is being dumped to the crushing plant, then this oversized material, to break it down on the grizzly itself, there will be your hydraulic rock breaker. They will be having a rock breaker with an impact and hammering action, they will break this oversize so that it becomes smaller and they will come it. So, but sometimes this blocking may come with a bridging. The smaller particle also can block the flow of the material to your this crusher. How? Because these two things, or sometimes the particle they can come in a zigzag manner and they form a bridge. So, this type of problem may occur if it is there, then you can, by creating a vibrator or putting something, you can easily do it. Depending on the problem, how it comes, you will have to observe, and then in the field you will have to solve the problem. Sometimes it becomes choking, or a complete or partially complete stoppages of the downward flow is getting blocked, because whole the material is getting stuck over there, that is a choking. Now, when a choking takes place, there will be a choke point where the capacity of the crusher is minimum. Normally, if the if the crusher is not giving enough force to crush over here, that may be the choking point in that crusher. Depending on the design of the crusher, depending on the curve what it is there, the choke point can be different. So, many times while maintaining, while designing, these points need to be looked into. Then other thing is that how you are feeding the material to the crusher. As I said, there could be by a grizzly, or there could be, say, when a truck is loading the whole material over there. This is a gyratory crusher, you can see over here. Now, when the material is coming, you are giving a choke feed, that the material can get fill the whole crusher, and it is by that, and then when it is moving, the material is pushed, that is a choke feed things. Sometimes this our in such a gate they compacted, and inside that it get packed, that is also an issue, and the reduction ratio, as I have already told you. So, these type of terminology are very, very important in your designing or in the operations and in the practical field. Now, that reduction ratio, that is how will you decide, because your run of mine, whatever is coming out of the mine, that material may be having a different type of fragmentation depending on the your blasting. So, many a time when you are that mine to mill concept is nowadays very common, that is you design your blasting in such a way that your reduction ratio required in the plant, in the crushing plant, is not very big. That means, you already get a fragmented one, then your energy required in the plant will be less, and that is why it will be much cheaper. Now, the amount of the rock in the crusher, how much it will be coming, it will also, it will have to, you will have to see that what is the percentage of voids when your material is fed into the crusher, there whether they are getting as a very compact packing they are getting, or there is some bridge is there. So, in between void is coming, depending on that the reduction ratio as well as the energy that will be affecting. That is your what type of toughness of the rock, that will also will affect your selecting that what should be the reduction ratio, and the angle of inclinations, and that exactly what is this angle of the gyratory crusher or jaw crusher, what angle you are keeping over here, that is also a, and also the speed at which that operation is going on. That is, if it is a jaw crusher, at what is the blow per minute it is giving, or if it is gyratory crusher, how many times in per second it is giving the gyration. So, those are the factors that will be affecting. So, telling about this, which is a very general things, and all of you must know. Now, let us talk about this, the cone crusher, which is for secondary crushing you are using. That you know that is here the whole operation will start, you will have to get the feed will be coming through this chamber. You can see this chamber is made by this concave shape over here, and this cone is there. Now, you may see that here this angle, exactly this depth is less, but in case of gyratory crusher this depth is more. This is the difference of a gyratory crushers and the cone crusher. Both are having a mantle. This is also a mantle, but here the mantle height is less in case of cone crusher, and that is your open side setting. That is, it is exactly because of the eccentricity, it will be moving like this. So, when it is moving in this as a gyration is also here, you can find here how this much getting opening, but here it get closed. When and then when it will be rotating, during the rotation time, once it will get open, and then it will get closed, and then it will get open, this will get closed, like that exactly it will be doing in every rotations. By that the particle is giving the compressions over there, which will be more than the breaking strength of the rock, and then the things will be breaking. So, here the mantle is the moving part and gyrates in an eccentric motion, just like the gyratory crusher. That is, does not remain completely centered. The eccentric means it is not always staying in the center. That is why it is the gap between the mantle and the concave, that will be going on varying, and that will be allowing your bigger size particle, when the gap is getting, that is your your gate is getting open, that size of particle will be going down, and that it rotates about 4 to 7 revolution per second. As a result, that gap between the machine and the concave will be changing, and the material is getting pressed and open, like that they will get crushed. As the mantle move, it crushes the material against the concave at the points where gap is smallest, that is the stone is the fit to and then compressed against each other. The stone, there are already the rock is there, 2-3 different big size rock, they can get compress each other, there will be some attritions also, and then they will be breaking and falling down. So, now you know that this in your cone crusher, the basic thing is you are getting, that is your mantle, it is rotating over here, but the rotation is not about a center, it is going eccentric. Because of this eccentric movement, that your closed set or an open set, wherever it is there, the material will be flowing like this, getting this bigger particle is coming, it is getting slowly getting pressed over here, that pressure goes on continuously increasing, the material breaks. While breaking, their material to material attrition is also taking place, and the compressed force is also coming up. By this way, your crusher will break. Now, you can see a little bit more analytically what is happening, that when it is rotating, at that time the material is moving from your that at the bottom side. Once it is closed, after some time it will get open. That means, as you see here, this one when it will be rotating, depending on it is going 90 degree, then it is going again 180 degree, 270 degree and 360 degree. During this 360 degree operation, once this your open set, this will become closed and this side will become open. So, as a result, this when it is rotating like this, that you are getting at any point, if you take in between your concave and the mantle, that space is taking as a sinusoidal way. So, this is where exactly the mantle and the concave, their distance, it varies, and whenever the distance become more, the pressure is less, but whenever distance is making small, that means that rock is getting pressed, and that will be giving your whole crushing energy to it, and it will break. Now, then what we learn from here, that the whole this crushing system, it is working, the crusher, your feed is coming, and then your product is going. In between, to control that how we will increase the efficiency of it. To increase the efficiency of it, we must know that all that phenomena, the blocking is not taking place, packing is not happening or bridging is not happening. It will have to smooth all the time, the crushing should take place and the material should flow. What is most expected is that whatever the material is coming, it is going down, that from the your entry point to the exit point, the material is flowing. At what speed it is flowing, then only you will be knowing that how much exactly material you are getting and cutting. So, that is why if you need to detect that is how will you detect the feeding system. There you can have your online detection system for knowing what is the size and then how much quantity of material coming, and then in the outside that where it is going, there you are finding what is the size and how much material is going. A material balance will have to be maintained. If the total quantity of material, total meter cube which is coming over there, definitely the whatever is going out the meter cube will increase. You have studied about the Rittenjust formula and all that thing, that when it is getting crushing, more surface area and more volume is created. But if we know that the weight will remain same, so by a study we can find out a correlationship, that if our crushing is this much is happening, that same material will have to go, but by that how much volume has increased, from that you will know that exactly your size reduction has taken how much. So, like that your data to be collected from the system, and there whenever you make these things, that by sensing it you can sense the things by putting a sensors of your that is by visual sensors, you can take the image and that image you can process, and then you can have the online weigh system in the feeder, and then also that feeder is there at the feeding side, also a discharge side, also a feeder for the subsequent that is your transport mechanism. So, what are the parameters you will be detecting, and from that you can develop what is called a crusher model. So, this is done in the industry, you get a little bit of interest of it, then you know that what is that physics and how the engineering is done over there. The most important thing is there, a cone crusher will be delivering at a 4:1 or 6:1 reduction ratio. Now, as the set close side setting tighter to create a finer output. If you are having a very small, that means you are increasing the increasing the reduction ratio, and you are trying to get a uniform material over there. So, what basically it is doing? It is whatever the primary crusher did, their material you are reclaiming, taking it over there, and then you are giving a secondary crushing product. That depending on your processes required, depending on your mineral you are using, this can be different. You can have that your secondary crushed product may be your 0.5 centimeter, or it can be 2 centimeter, it can be 5 centimeter, depending on in what type of processing you can do it over there. So, in the real life plan, we will be talking about what is the capacity, what is the size of the feed, and what is the size of the product. And for that, what we will be monitoring? How much energy is consumed, how much time has taken. If the energy consumption should be minimized, your time required should be optimized, and the matching with the subsequent operations should be compatible, then your crusher selection is proper and you will be getting economic life. That is cone crushers we have said. Then there are other type of crushers, you might be hearing about that, what is called your that impact crusher. Now, impact means if you are having a rock and then you are having a hard surface, by gravity if this rock comes and it falls on that rock, then what may happen? This rock will get shattered. That is exactly as a gravity impact you have got. But sometimes this impact can be dynamically all the time you give. That is that impact crushers. I think I told you last time, you can do an experiment with the at your home, allowing different type of rock and then put, and then you find out what is its crushability. Your particular rock, whether that is your the limestones in a different mines or that coal from different mines, they may have a different type of crushability. Now, if a system, if you are need to reduce the size, how will you determine that the crushing by a gyratory crusher or a cone crusher or by an impact crusher will be having a crushing product at less cost? For that, in a laboratory experiment is necessary, and you can create your own experiment. At sometimes you can find out, take out 2-3 different rock and you find out which one is easily crushable just by a gravity making them to fall and they will break, or where we will have to do a hammer, and in the hammer also some rock, how much energy will have to be given, what should be the size of the hammer to give a rock. Say if you want to break a rock, a granite, that what should be the size of the hammer to fall it from, and then how many times the blow will have to be given. If you take a coal, what should be the size of the hammer and how many times the blow will have to be given. You can design number of experiments and you find out what is the specific energy required by a different method. If you want to give a pressure, then how much exactly energy you will have to press to break it over there. So, then that impact, or in a dynamic one, if the rock is moving, your feeder is giving the rock into a chamber in which this is a plate with that you can see here is the hammer plate, and this is your plate, fixed plate. This rock will be coming and giving an impact over here, and while it is coming at that time, this will be rotating, these rotations will be giving also an impact over here, and then they will be getting broken and that small pieces will be getting. So, this as because how robustly you will be designing, those of who are mechanical engineer, your job will be that exactly how you will design this component and rock. Now, for doing that, exactly the how you will be allowing this chamber to operate, that is the designing part of the mechanical engineer will do. As a material handling engineer, you will have to select the right type of equipment, that your chamber, that where the impact will take place, how will be having this your impact apron. These are impact apron which are there, and this is Sandvik has created such type of machines where you can have that exactly depending on that what velocity, what size of material is coming, you can push these things closer to this, because when the material will be coming, a big size material has come over here, it will get stuck and this rotation will be giving a impact over there and it will go. And then there could be number of them that they will be giving repeatedly over there, and then they will get a more finer or a grinding will take place. So, this is the way in a by feeding at one point how much time it is having a retention time over here. That means, when the time is at the time a batch of material is coming over here and that same batch of material is going over here, the time which is taking over here is called the retention time. Depending on that retention time, your that feeder which is feeding the material over there, that feeder belt at what speed it will be coming will have to be compatible. So, that is when you will be studying in a field, this need to be matched. So, designing of the that your crusher will also require that to design how the feeding is taking place. Now, this is the rotor which is rotating over here. In a crusher, it can be a vertical rotor, it can rotate like that, and also it can give a hammering actions, or it can be in a trough where that is your hammer is in a horizontal shaft and rotating over there, and they will be giving. There are lot of different design is possible, you will have to do. So, you have seen that the impact crusher has got a different way and the cone crusher does it different way, but what is there, because it is a impact is given additionally and you can change the blow, you can change the pressure, as a result you can get a high reduction ratio. And then sometimes when you are giving a pressure in a cone crusher and breaking, the fine product they may be coming with some crack, under the pressure inside a crack will get developed. Now, that when that final product will be coming out, it may be weak. Now, depending on what type of operations you are requiring outside, if your product, whether there should be residual stress in the finished product is good, a crack inside the product is good for the subsequent process or not, that will be telling your, because normally as you are giving an impact over there, whatever is coming because of the brittleness and all, it will get shattered and that they will break and they will not remain any residual crack much, as it is done in case of your cone crusher. Now, we can have a good adjustability, and the products that your processing engineer, they do a lot of things that how it is to be adjusted with their subsequent operations, and then the product quality can be maintained, particularly that if you are to do the sieving or screening actions afterwards, that our required size, the retention of the required size, that may be increased more. These are the sum of this. Now, one thing is there, it can go to the reduction ratio 1:10 to 1:20. So, these are the possibility over there. Then the next type of this, after that we have some of the attrition crushing, in which I told you earlier also in the introductory classes that if you get a ball mill or a rod mill, the material along with a ball mill, if it is rotated inside a ball mill, they will be starting, we are giving a lot of attrition will take place and the fine products will be coming. But this when you are telling about this, your crusher secondary crushing can be done by to roll. If your material is coming, we are having these rolls which some of this impact it, and then the material is just these two will be rotating over there and they will get cut over there, that broken over there. Sometimes this rotating roll, a cylinder with having some of that impactor fixed over there, and this is the that your chute through which it is coming, that the material is fed, they will get crushed and then the products will be coming out. So, the other thing is that in the impact crusher, we said that it can be horizontally, this is placed over here, you can see that this is rotating like this, material is coming from here, and this cylinder is horizontally, it is just rotating over there, the material will get crushed, and from here the material will be dragged down to over here to get reduced, that it can fall like this. So, there are different designs, different makes are available, you will have to charge and find out. That the roll crushers which I said, that it could be only straight roll, or the rolls will be having this type of that is your impactor, by which when these two rolls will be rotating from the opposite directions, and then they will be giving that impact inside the chamber, they will get broken. So, there are different way we can do this secondary crushings and then their operations, but you will have to learn how to manage the handling system, and your learning will be there when you take some learning activity. I wish that you prepare a document with necessary diagram to explain what are the constructional components of a cone crusher. We have discussed little bit, but by listening to the class and then they will not do, you will have to do by yourself, at least draw a freehand sketch, then only you will be able to do it. And then after you know the component, you yourself will ask, what is the function of the mantle, what is the function of the concave, what is the function, why the gap should be there, how we designed that, how much the gap will be there, how the eccentricity is coming, we have get eccentric shaft, that what are the drive component of the eccentric shaft, whether we will be giving a hydraulic drive or electric drive with a gearbox, and then how the bushing will be made, those things a little bit of more mechanical detail you can do it by your self studies and preparing this document. How do you measure the efficiency of a cone crusher? That is how much your input energy and then how much is the product you are getting. You make some, what are the different indicator that industry they say is the key performance indicator, that how those key performance indicators are measured, you need to find it out. What are the merits and demerits of cone crushers compared to a jaw crusher? Or another work you can do if you are interested, these days when I see those GIF, that exactly there is a freely available, that your softwares are there, you download it, how to develop a .gif file, which will be giving you make it over there, draw the sketch, very simple pencil sketch and over there, and then how you see that this can be given the animations, it will be going on doing over there. So, those are the today's students should develop your own GIF, at least for one item you do, it will be a good interesting learning exercise and you can do it over there. There are many books and the normal textbooks, that Willie's book on mineral processing engineering. Then there are number of open that is public domain articles and that internet informations are there. I request you learn those keywords, whatever has been given in this. These are, you take one or make a list of at least 10 or 15 phrases as a keyword. Make that you do not take a lot of time. Our topics, we have got lot of different topics to be introduced for your learning, and you make for every class at least 7 keywords you pick up, and for that 7 you read at least 7 articles in 7 days in a week for all this, and then you find out, yes, this one is important, interesting, do a little bit of another 1 or 2 hour study of that. Whatever the minimum you study, that is the best things. With the minimum study, you prepare one document, that will be sufficient for your learning exercise. So, size reduction is an important function in mining and metallurgical as well as in the food industry, and reduction of energy required, that is for reduction energy is required, and cost of this operation, maintaining the safety and environmental challenges, the scope of technological innovations are plenty. You can innovate new things, new way of doing things, but for that you will have to see, find out how exactly that your everywhere it is crushed, whether it is you go to atta chakki, there also the things are crushed, and then whether you go to any that your even you do a different type of crushing for taking out the juice, that is also in food industry different type of handling and crushing takes place. You are advised to undertake exercise to simulate the crushing process and to develop mathematical model of crushing operations carried out by using various machines. I do not know who are how many of you will be really interested, but yes, the simulation and model development for predicting the problem, that if some of you are mechanical engineer, you may think of what will be the tribological aspects of this crusher operations, where the friction wear will be taking place, where you need to lubricate. The mechanical engineer may look into a crusher in a different point of view. As a processing engineer, you will be looking into a different field. That is, as a mining engineer, you need to manage, you will be looking into the how the cost benefit is coming. So, depending on your interest, take the things. I have just introduced this. Thank you very much.